Hi everyone. So last class we were working on mostly set notation. And so it's important that you understand the difference between set notation and interval notation. So with interval notation, you're using the square or round brackets, or what we call open or closed. And remember that the square means that the value is included. And if you drew that in a dot, you'd have a solid dot, and your inequality would be one of those ones. Now, this one is the value is not included, which means you'd have a hollow dot and one of these inequalities. Okay, so that's interval notation. In interval notation, you can use infinity. Use infinity if you only have one limit. So if you only have an upper limit, like say the maximum value is 10, your lower limit would be infinity. So it would be something like that. And let's say we used a hollow dot. Likewise, if your graph looked like this, -1 to whatever, you draw your lower limit, and then infinity would be your upper limit. And infinity always, always, always gets one of these brackets, because remember that infinity is not an actual number, it's just a concept. So that's interval notation. And then we have set notation, and set notation is using these brackets, the curly brackets, and you have such that, or sorry, belongs to and such that, okay? And over here to denote which kind of number it is, you have real numbers, integers, natural numbers, whole numbers, and then rational and irrational. And remember that it's mainly these four that you're going to be looking at. So you can write out your set notation for domain or range. And if you're unclear on that, make sure you go through the notes and just review that again. So let's start on today's notes. So we're going to look at continuous and discrete data. Now this came up a little bit in the very first assessment assignment we did, that little math review that we did. And so remember that when we talked about it, it is basically just what the English word sounds like. So continuous, when you think of something being continuous, it doesn't stop, right? And so on a graph, continuous data is connected by a line. Okay, so it's a connected set of numbers. So if we look at our two graphs here, graph 1 and graph 2, you'll see that this one has arrows on it, right? And this one doesn't. So we don't know what kind of dots are here, but let's just put solid dots. The type of dot doesn't really matter so much as recognizing that A, they're both continuous, and then recognizing that there's restrictions on one and not on the other. So this being the line, right? The line shows that this is continuous data. And then which numbers are included in here? And I want you to think back to when we did set notation, when we had that very last example. So are there any upper or lower restrictions here? And there aren't, because there are two arrows. So this is all real numbers. Okay, so if we want to do part of set notation, remember this isn't total set notation, but that's what that would look like. Whereas over here, this is still real numbers, and whenever you have a solid line, that's going to be real numbers, because remember we talked about how real numbers are all the numbers that we think of, like, and all the numbers on a number line, like -5 and 5 and 0 and 1, but also all the decimals in between, so 1.5 and 2.89, all those things count as real numbers too. And so for x, the values would be from 0 to 5, and for y, they would be 3 to 7. And this is not any sort of notation, okay? I'm just quickly interpreting the graph for you, okay? So if I ever ask for, say, set notation, and you write something like this for me on a test, that's not what I'm looking for, okay? So notice that there is always another number between any two given numbers. So if we look at graph 1 and we plot 2, 0 and 3, 1. See how there's this line in between? That means that every single value in between on that line counts. Okay, so it's not just whole numbers that we're looking for, it's everything in between. So, for example, like 2.1, 0.1, or 2.5, 0.5. Okay, so the points in between can be decimals or fractions. Okay, again, normally when you're working with graphs, you're going to be choosing, 2, 0 or 3, 1. But you just have to realize that if it's continuous data, points like this are also included, even if we don't normally use them because it's just inconvenient and a little bit messier. Okay, so continuous data involves real numbers. Okay, so that's when we write something like that. And remember, when you wrote your interval notation, you'd have x such that your inequalities, and then this is where your x, all real numbers, goes in over here. And continuous data includes things that can be measured. Okay, so think of things that you can measure with some sort of tool. So time, we measure time with a clock or a stopwatch. Other things that we can measure include things like height, right? You can measure the height of something, the volume of something, the distance of something. And all of these things do not have to be nice, clean, even numbers, right? Like your height, you're not either, so let's go metric here, you're not either like 170 centimeters or 171 centimeters. If you're being exact, you could be 170.5. And same with volume. If you look at any of the volumes on any sort of cans that we have here, we use the same sizes as America, but they're using the imperial system and we're using the metric system. So we end up with all sorts of weird sizes like 327 mils and things like that. So it's anything in between. Same with distance. You can drive 1.3 kilometers, right? You don't have to drive 1 kilometer or 2 kilometers. So continuous is anything that can be measured, which leads us to discrete. And discrete data is not connected. So there's no line. You have separate data points. So if you look here, you have separate points. You have no line. And there's no data points between or in between. Say that. So if you look like here or here, there's no data points. Right? There's nothing in there. There's only, say, 0.22, and the next point is 3.3. There's no 0.2.5, 2.5. That doesn't exist here. So there's no line. So where continuous data was real numbers, discrete data are things like integers, and the symbol for integers, remember, was I. Whole numbers, what was the symbol for whole numbers? It's W, and then natural numbers. Integers are numbers that are on a number line. So something like -2, -1, 0, 1, 2, 3, etc. And you can go this way also, right? But do you see that they are exactly on a data point? Whole numbers and natural numbers, remember these are very similar, except whole numbers have a 0, and natural numbers just start at 1. And remember that natural numbers would be found in nature. So nature would not care if there are 0 elephants in Saskatchewan, right? That's not even something that's considered. They would just start counting at 1. Whereas whole numbers would be numbers like we use, okay? So things like money, right? And I know that you can have debt, which would be negative money, but you can't physically hold debt, right? So this would be like, how many coins are you holding? And you could be holding 0 coins or however many like that. So discrete data is anything that can be counted, okay? So people in a room, something like the number of, say, athletes on a team. So if you have a team with 30 players, you have 30 players. You do not have 29 and a half players or 32.94 players. You need a natural number or a whole number for that. Like the number of legs on a horse. So a horse will not have 3/4 of a leg, or not naturally anyway. So you'd say that there are, 4 legs on a horse. Even if, the horse, was, born with part of a leg, you'd still say that there are 4 legs. So things like that. And then say the number of houses in a city. Okay, so things that are their own discrete object. Okay, and continuous data is things that you can measure. So when we show this on a number line, we still have to show domain and range separately. That doesn't change. But now what will change is if we draw a line or if we draw dots, and what kind of dots we draw. So when it says domain is all real numbers, so I know that this is going to be a line, okay? And I don't know which way my line is going to go, so your arrow could go the other way. Then I look at greater than or equal to, so I'm going to need a dot, and I'm going to need a solid dot, -5. So greater than or equal to -5, that means -5 is my lower limit. So here we go. And it's all real numbers greater than or equal to. So I draw a solid line to the right because it's greater than or equal to. So remember that every time you read one of these, interpret the whole sentence and then draw it out. Domain is all integers greater than or equal to -5. So integers means there's going to be no line because this is discrete. Greater than or equal to, I will still have a dot at -5. So I'm going to put that dot at -5. And then I have to think of my integers. Integers can be negative numbers and positive numbers. So I can start at -5, but then I have to put, instead of a line, because a line would say it's continuous, and that's not true, I have to put little dots all the way up. And you can, this is all integers, so at one point you can just put an arrow, okay? Because it will just keep going. Every integer that is above -5 will be included in this. Okay, so now we have, what kind of notation is this? It's got a curly bracket. This is set notation, okay? So again, for your quiz on Tuesday, know the difference between set notation and interval notation. So this is set notation. I've got y as a variable. So what is this showing me? This is showing me range. Okay, so y such that y is greater than or equal to 2, y is less than or equal to 10, y is all natural numbers. So first of all, let's identify that because I have greater than or equal to and less than or equal to, I have solid dots. And then n. N is natural numbers. Okay? And this is a natural number, so this is discrete, which means that I will not have a line. Okay, so for each of these, until you get comfortable with them, write out all this information. Then it's just easier for you to know that you're headed in the right direction. So I have to go between 2 and 10. And then it's every natural number in between that. Natural numbers are anything above 1. And so between 2 and 10, I'm automatically above 1. So I can just fill in all these little dots. And that's it. I don't have an arrow here because I have two limits, an upper limit and a lower limit. So I have to stay within those limits. Okay, and then here. So if you want, pause the video, try this one on your own, and then come back to see what I do, okay? So I'm going to look at this. This is x, so it's domain. Greater than, so a hollow dot. Less than or equal to 6, so a solid dot. Whole numbers, so this is discrete. And it can include 0 because it's a whole number. So my lower limit, and sorry, discrete means that there is no line. Lower limit is a hollow dot. Upper limit is a solid dot. And then I just fill in my dots in between. Again, I don't have an arrow here because I have an upper and a lower limit. I don't have an arrow because, sorry, I don't have a line because there's no, I don't have an arrow because there's no upper, or there is an upper and a lower limit. Okay, I don't have a line because it's discrete data. And then the last one, and again, see if you can pause the video and come back. I look at this one. The first thing that stands out to me is this is real numbers. So this is continuous, which means I can have a line. Then I look at my inequality, and I only have one limit. So, oh no, sorry, there's the one. I didn't even see that, sorry. So it's greater than or equal to, or greater than 1, less than or equal to 6. So I put in my lower limit, I put in my upper limit, and I draw a line. Because it's everything in between there. It can be 3.5, it can be 4.1, it can be everything in between there. Okay, so there is a worksheet on continuous and discrete data. And I am going to collect this for Tuesday. Okay, so it's due. The set notation worksheet is not due. That one is, the key is already posted. Okay, there's going to be one more video. Okay, so make sure you watch both videos.